IUPAC naming is what I decided to do my final project on. What is IUPAC naming? Why is it so important? IUPAC naming is how we name our organic compounds. The term IUPAC stands for International Union of Pure and Applied Chemistry. Using this form of naming organic compounds allows there to be consistency to all the possible names. Also, this allows for each name that is given to an organic compound to be completely unique to that specific compound. It makes it easier to understand what compounds are being spoken about without the possible confusion of common naming. Something that I found quite interesting when learning how to create an IUPAC name was that it's usually a good idea to start at the end of the name, the suffix, rather than the beginning. I thought this was quite cool because you're normally taught to write from left to right, but in creating IUPAC naming, it can be easier to write from right to left. Step 1 of IUPAC naming. The first thing that you want to do is recognize the functional group. This will give you the suffix of the name, which is the easiest way to properly form the name. What is a functional group? A functional group is defined as an atom or a group of atoms joined in a specific manner which gives the chemical properties of the organic compound and are the centers for chemical reactivity. To the right, I have a few functional groups that have their suffix beside them. These are usually the endings of names for organic compounds. In this course, we generally only touched on the top 4 functional groups, being that of an alkane, alkene, alkyne, and alcohol. However, the rest are good to know. A little bit more detail about functional groups. The functional group present in an alkane is that of a single bond between 2 carbons. The functional group present in an alkene is a double bond between 2 carbon atoms. The functional group present in alkyne is a triple bond between 2 carbons, and the functional group present in alcohols is when a hydroxide is attached to a carbon atom. In this slide, I just wanted to touch base on the main functional groups that we have used thus far in Organic Chemistry 1 and why they are labeled this way. This way, you can have a better understanding of why we use them when we label compounds. Step 2. Prefix. When beginning the second phase of naming the organic compounds using IUPAC naming, it is to find the longest continuous carbon chain that contains the functional group. Once the longest carbon chain is identified, you should count exactly how many carbon atoms are in the chain. This will give you the ability to determine the prefix of the compound's name. It is very important to note at this moment that naming the longest continuous carbon chain does not mean that it has to be the straight chain. I have created a table to the right of this slide as well as with an outline of the number of carbon atoms and what prefix goes with each. 1 meth, 2 eth, 3 prop, 4 bute, 5 pent, 6 hex, 7 hept, 8 oct, 9 non, and 10 dec. These will be used a lot, so you need to be familiar with them. Step 3. Numbering the carbon chain. After determining the longest continuous carbon chain in the molecule, it is time to number each carbon. Always keep in mind that you want to start your numbering at the end closest to the functional group. If the chain of carbon is from an alkane with no branches, then you start from either end of the chain and begin numbering. However, if there is a branch of any kind that holds something other than a hydrogen, you will be numbering from the end closest to that branch. It is important to know that when you are numbering the carbons that you recognize its functional group, because unless it is an alkane, you need to ensure that numbering of the chain has the functional group at the lowest possible number. To the right, I have a few examples of how to properly number an alkane with branches. In the top left, you see a methyl branch from the second carbon in the carbon chain. On the right, it has been given the number 3 for its position. However, this would be incorrect because the placement has the second carbon is fewer than that of the third carbon. Underneath, the same method would need to take place, except since there are 2 locations of branches, you would want to number that chain with whichever would cause the least amount if summed up together. This means that on the left you would have carbon chain 2 and carbon chain 4 added together, which would give you 6, and on the right you would add 5 and 3, which would give you 8. Therefore, the left has the fewer sum and is the correct way to number the chain. Step 4. Identifying branch groups. When identifying what type of branch is coming off of the main carbon chain, it is important to count how many carbons are within the branch. Once you have counted how many carbons are within the branch, you can then refer to the way we created prefixes in step 2. Using those prefixes and ending them with YL will give you the name of branches. Note the position of the group on the main carbon chain. If there is more than one of the same type of branch group, then both numbers must be listed and one of the prefixes describing how many branches of that kind there must be used. When you're writing out the full name and where the branches are, you have to be sure to place the numbers in numerical order with the branches, starting from the smallest to the biggest, then giving the prefix describing how many there are and then the rest of the name. It is also important to know that the branched groups must be listed before the name of the main chain in alphabetical order, being sure to ignore the prefixes di, tri, and tetra. Examples of identified branch groups. In the images to the right, we have 3 different types of alcohols with their individual IUPAC names. You can notice that each of these has a branch that has been placed into the naming of the compound. The top left one has a hydroxide branch as well as a methyl branch. Due to the hydroxide, this causes the suffix of the name to become OL, signifying that it is an alcohol. When writing out the name, the methyl and its placement in the chain comes first in the name because M falls before P in the alphabet. Then you add the carbon number that the branches 1 for each one, and then you have the IUPAC name. I encourage you to try and understand why the other 2 examples on your own have these names. Step 5. Alkyl halides. When dealing with alkyl halides, the halogen atom is treated much like a branched group. There is a slight difference in the naming. To name them, take the name of the halogen atom and replace the INE with an O. You still give the halogen a number to show the positioning on the chain. If there is more than one halogen atom, list the numbers and be sure to add a prefix. All halogens must be listed before the name of the main chain in alphabetical order. If there are no halogen atoms, this step can be ignored. To the right, I created a table showing you halogens and the names that would happen once you replace the INE with the O. Step 6. Combine it all together. Finally, you can combine all the elements of naming together into a single word in the following order. Branch groups and halogen atoms in alphabetical order. Be sure to ignore the prefixes. Then the prefix of the main chain. Then name ending according to the functional group and its position on the longest carbon chain. Even though this is the last step, be sure to remember that it's easier to identify an IUPAC name if you know the functional group ahead of creating the name. To the right, I have placed a video that isn't very short. It's about 8 minutes long, but it allows you to be interactive with steps and explains it in motion. I thought that I would put it in here for hands-on learners who are like me and would like to follow the steps visually and mentally at the same time. Last thoughts. Using IUPAC in the future. Overall, I chose to use this as my topic because it is at the base of organic compound and organic chemistry. I think that mastering IUPAC naming is something that will help you through your entire journey as an organic chemistry student and even after in other classes. The ability to break down the name and understand the true makeup of the compound can advance your knowledge so far of each compound we study. I think IUPAC naming is vital in this class, and I hope that I have shown good evidence as to why. I hope that you've been able to learn something from this presentation and you can take it into your future classes. I hope that it is something that you will remember when taking apart organic compounds and being able to understand why they have those names. This has been an amazing class, and I hope to be a part of it again in the future on a different level. Thank you so much for your time, and have a wonderful day.